I think we got Joel ready.
On the phone. We just
Joel
need to get the Skype
mute the
video
audio on this one so that we don't clip it in. Great, guys. Thanks very much.
All right, Joel. Your video ought to come in any minute, so you're set to go.
I can see you guys.
Oh, can you?
You're live, and I believe I'm live too.
There you are. Very good.
And then we want to full screen it.
Good afternoon, Value Electronics.
Okay, the audio's going to be better today.
Do we have audio and video?
Yes, we do.
And ready to go. Good afternoon. We're here to talk a little bit about how we look at images, quality, see what we're going to find for. I've improved them. Let's see if I can fix. Audio should be better now. I had an echo there from both Skype and phone. Is that clearer?
It's excellent.
Okay. Excellent. If we head over to slide number 1. First thing I want you folks to look at is where some of the TVs that you're looking at came from. These are 2 of the newest factories on the planet, both funded by Japanese currency. The first on your left in Sakai City, the sharp plant that came together. It's also owned by about 33% by Sony. So the new Sony you're looking at right there in Value Electronics is the first one we know of from this new plant. That plant is the largest factory ever built in Japan. Holds some interesting stats that the Wall Street Journal wrote up. Corning Glass, who makes the majority of the glass for most of the flat panels in the world, built a custom plant right on site to save shipping, transportation, and fuel. So the foundry produces glass, goes through a conveyor belt, ends up right inside the shop/Sony plant. Tremendous savings and efficiencies. To its immediate right, you're looking at a Nagasaki plant from Panasonic. An interesting scenario. Are there any Pioneer Elite owners in the room? Raise your hands, I can see some of you. Okay. People who actually did the engineering behind your plasma leads. By the way, are you happy, Pioneer Elite owners?
Oh, yeah.
Raise your hand, yes. One of the best TVs we've ever seen. The engineering crew, all 200 of them, is now working for Panasonic.
Wow.
Putting new things together in our plant. So you've seen the changes in Panasonic A, the plant, being the engineering team. The Pioneer plant that knocked out your television sets was, these days, a paltry $475 million, which we used to think was a big factory. Engineering efficiency there is amazing. Technology is phenomenal. And Kevin, go to the next slide.
Okay.
Would you think that in these factories, they've got every bit of calibration gear that either Kevin or myself owns? Well, Kevin and I share some of the same tools. We both decided that one of the Konica Minolta pieces, the CS200, is ridiculously expensive but addicting, and you kind of have to have it because it's one of the best portable tools we've ever seen. So it's quickly become our tool. It's used all over the world in digital cinema, and they have tons of them in both factories. So these factories know everything about television, including what we do for a living. And we've had the privilege of working with a number of these people for years. But looking at the next slide, what guides factory calibration? Unfortunately, your room, your needs, your wishes, your desires are not what guides factory calibration. With all the equipment they have, the 2 masters they serve have nothing to do with our needs. One, of course, is the traditional retail lighting and showrooms where they must build things to be competitive. So we've known that for decades. What's brand spanking new, and unfortunately ISF is part of it, Energy Star ratings and the CEC, which stands for California Energy Commission. Any of you have seen the debacle for the specs that come through on that? Because a bit of a scandal in the industry. Some of the specifications we gave them on power consumption versus light output were, in our minds, being aimed at specifications that would limit light output on television sets. Instead, they decided to limit current consumption and square inches. So you're going to find some of the new TVs come out of the box dark. So for the first time in the 15-year history of ISF, I as a calibrator, and Kevin, you probably tell me the same thing. You find a lot of these new TVs now too dark at the box?
Absolutely. We're driving light output up instead of down in the process.
It's a total turnaround. So if you pick the 2 options you have when you take your TV home, one is home, it's too dark. One is store, it's too bright. Neither works for us, but again, they work for the people who pay the bills for the majority of factories that are looking at tens of billions of dollars. Next slide, please, Kevin. One of the things we want to talk about all day, and Kevin will spend lots of time on, is basically analyzing quality. So the perception that we have globally, unfortunately, actually, calibration's growing nicely around the world. I've done 2 sessions in Hong Kong, one in Guangzhou, one in Beijing. I'll be back in Hong Kong in November and in Shanghai in December. We'll be on over to London and Amsterdam in the first quarter of next year. So the perception around the world is TV pictures are better. And in a sense, these are, at the same time, like the old cliche, the best of times and the worst of times. And like most cliches, they start out because they're true. We have the worst pictures out of the box that we've seen in 15 years of business. Just plugging things in doesn't get you much of a good picture compared to the old CRT, which was our gold standard. However, the controls in these TV sets and the potential quality they have with some simple adjustments are the best we've ever seen. Going down to height, the industry is unfortunately full of hype. Not much good data, but height. One thing hype did was produce a number that all our customers know, and that's 1080. They don't necessarily understand I or P, but they know 1080 means something. The marketing now is almost embarrassing. In Hong Kong, the largest retailer there is called Fortress. They're a little different as far as regulations from the mainland Chinese laws. False advertising in China puts the owner of the company or the CEO in jail. Some people there are hesitant to run ads that call something an LED TV set. And Kevin and I are kind of a little aghast because we've never seen marketing people actually develop a new technology. Only technology developed by our engineering firms. Calling something LED TV is kind of strange. Kevin Hunt, writing for the Tribune, has actually done good things for mainstream magazines, and a few folks have seen his stories. But he was actually writing something on the ABCs of LCD saying, guys, it's just an LCD with a backlight. That's an LED, which is what it is. But I was at dinner 2 weeks ago with some friends, and they were determined to buy an LED TV because they weren't happy with the viewing angle on their LCD. And when I told them it was just an LCD with an LED backlight, they didn't believe me. They, of course, don't know what I do for a living. I said, okay, trust me, it's an LED backlit LCD. When they read it in the Tribune the next day, they said, hey, you're right. It's kind of confusing out there. I don't blame my friends. They read in the ads, they see what's going on. We've got 3 manufacturers now going LCDs and LEDs. The reality is, they're still good TVs. Set up properly, they do good jobs. Energy efficiency behind LEDs is very interesting. Some of the things Kevin will talk about, spectral power distribution, the actual wavelengths of light that we all see are actually very good coming out of LEDs. The reality is good. And the last question on this slide, have we gone too far? Do any of you ever see a newscaster on CNN called Robin Meade? Does that name ring a bell? She has her own show now. She is quite spectacular to look at, not bad. In the morning, when I'm on the road, I'll often flip her CNN show on just to see what's happening. And in North Carolina, not too long ago, I'm watching The Machine, which is Robin Meade. She's a phenomenal newscaster. She actually stutters. I've never seen this woman stutter. She is an ultimate professional. She goes, according to this the survey, she lost it for a second. She goes, according to the survey, the average American male would give up sexual relations for 6 months for a 50-inch plasma TV set. Have we gone too far? No, we think this is hysterical. Robin Meade, being pro, he had lived it and said, these are probably the guys who weren't having any relationship anyway. Nice to see that where the newspaper is, where you see Kathy cartoons and Far Side cartoons, all these things talking about television. Oh dear, what's going on? Kevin and I have been using these demonstrations, so it's nice to be in the public eye. Next slide, please, Kevin. The alter ego of television making pictures is taking pictures. How many of you own a digital camera that might be respectable? It's over $300 or so?
Hey, Ed, next slide.
Okay. We've had, as you know, a megapixel war for years. Would it Canon be considered respectable in camera technology? We can agree on that. So they would be state-of-the-art, but they're respectable manufacturer. Canon actually broke the mold last year. They had a G10, which I am misfortunate buying, if not liking, 14.7 megapixels. Looked at the camera, and I looked at the areas, the dark parts of my pictures. It was just riddled with digital noise. Not a watchable picture, even for my kids. They like it, it's okay, but I watch on a large monitor when I see pictures for editing. Not acceptable. A year later, what did Canon do? The G11, which is a superior camera, lowers the megapixel count. Goes down to 10 megapixels. And I'll credit the website. Any of you seen something called Deep Preview? Very good camera site, good technologies. Their term, I'm going to call it, is called pixel density. Seems that pixels in cameras read light, accept light, and produce a signal, an image. The pixels get very, very small. They don't get much light. So fewer, bigger pixels is better than more pixels, which means that many things, a simple number like buying those megapixels didn't get you a good picture. Quite shocking for most people, but you're looking at one brand in the room right now that's got a fourth pixel. In a pixel array of 1080p, all the pixels get smaller, so they also have some difficulties making light and processing. Processing and pixel size are significant issues that complicate things for resolution. Kevin, get the next slide, please.
Okay.
And here's something that goes to the heart of what we talk about. Here are two lenses. One from Canon, quite respectable. Anyone in the room ever heard of Leica? Raise your hand, please. Respectable camera manufacturer?
Yeah.
So if we're looking at a Leica that costs 10 times more for the same standard 50mm 1.4 lens, what would you get for 10 times the price of a Canon, which is already a good lens? Kevin, any guesses in the room?
Any guesses, folks? What
makes a lens worth 10 times the price when it's already sharp and good?
Higher contrast ratio.
Well, you get purity of glass, and light does not get disrupted as it passes through it. You don't get light scatter. So if you're looking at a scene that's a night scene where you've got bright elements and dark elements, you get better contrast, which in a camera, just like in a television, is everything. Let's go one more slide, Kevin. And I know yesterday we had some magazines running around. Do we have some magazines?
Yes, we do.
Geographic to people?
Absolutely.
Folks familiar with both these magazines? Which of the two, between National G and People, makes a better picture?
Geo.
That's right.
The question is not just does National Geographic make a better picture, but why?
Yeah. So, a lot of reasons.
Why would be the expense they take with the paper stock. Not the quality of the lenses, not the photographers, because both magazines share some of the top photographers on the planet. The paparazzi make money, they have good cameras. The photo paper that's used in National G gives us better blacks, hence better contrast, hence better picture. What I'd like Kevin to do right here is to have a little experiment. And Kevin, it's going to be difficult, but can you use your generator to send black to everything in the room?
Absolutely. It's set up
And if you turn the room lights out, I'd like all you
Indeed.
folks just to look at the pictures,
Are you ready for black?
and you'll notice a couple of things. The local area dimming UV flagship go black. They'll disappear. The plasmas will have some residual light in the room, and you should be able to tell that when you send something black, it may not be black. So if I tell you we're sending black to every TV in the room, and it should be pitch black, well, are you going to believe us, or are you lying eyes?
Alex, would you get Wendy to
Yeah,
shut
which
that
one's the
door
blackest?
or shut that TV off, please?
Kevin,
Yes.
which one's the blackest?
It is the Samsung
LED? Local area dimming?
local area dimming edge lit.
And can you send that 5 IRE? And let's see if there are any artifacts in the edge lit.
I think we can do that.
What I want you folks to take a look at is something we call dark field uniformity.
There's 5.
Is it uniform dark field, or are parts of it darker than others?
It's pretty uniform, I think. It's right on, especially.
Try 5, 10, and 15 just to give them an idea of what we look for.
10.
Is it uniform or non-uniform?
It's a little washy.
Little blotchy.
15.
Now, if it went pitch black, that means the measure of something that's called contrast ratio is totally meaningless. As much as Kevin and I adore our new meters, we can't measure black. Black by nature of being black is not measurable. So if we go from white to black, the contrast ratio has no number. When you divide by 0, you get no number. That's meaningless.
Yes, but you get a word called infinite, isn't it?
You get marketing terms out of it.